Okay. We're on number 17. It says convert moles to mass. So when we're given the moles of a substance and we want to change it to mass, we always use that molecular mass. So we found the molecular masses in 13, and you'll find it in 14, 15, and 16. But what was the answer for number 13? What was the molecular mass of sugar?
180.156.
180.156 G per moles, meaning that's how many grams of sugar are in one single mole. So if I'm trying to figure out how many grams are in 3 moles, but 3 moles of sugar, I would probably need to multiply this by 3. So I'm finding the mass, the overall mass of 3 moles of the substance. So I have 3 moles of sugar. And I'm trying to convert it to grams. I'm trying to change the unit to grams. I'm not changing the amounts of stuff, I'm just changing the unit. So there's 180.156 grams in every single mole. So we're trying to change mole. We're trying to get rid of the mole unit. So mole is going to go on the bottom. I have 1 mole. And in every 1 mole, I have my 180.156 grams of sugar. So now, as you can see, my moles, they cancel out. And I'm left with 3 times 180.156 grams. And then you use a calculator. Again, on your test, you can and should bring a handheld calculator, not a phone calculator. I'm asked that every single class. Can we bring a phone? No. You cannot use a phone on a test. So either borrow it from somebody that you know or bring your own from home or your locker. Yes. All right. What's 3 times 180.156?
540.468.
540?
Yes.
Is it really?
Yes. Yes, ma'am.
Okay.
You don't trust us.
All right. 540 what?
0.468.
468. All right. 468 rounds to 47. So I have 540. Really?
Yes.
Oh, I was thinking 3 times 16. Okay, never mind. Okay. We're good. We're good. Your calculator's right. Good job. All right. 540.47 grams in every 3 moles of sugar. All right. Any questions on that? All right. So number 18, you're going to be finding the moles of olympocene. If you look at number 16, you're going to be finding the molecular mass of olympocene, which olympocene is from number 4. So it kind of leads through the study guide. Number 19, you're finding the half mole of methyl acetate. If you look at number 3, methyl acetate is peppermint. And for number 15, peppermint, you're finding the molecular mass of peppermint. Methyl acetate is the, what is it called? The IUPAC name for peppermint because it has to do with its carbon structure. So methyl acetate and peppermint are the same thing. And then number 20, it says find the amount of moles for cinnamaldehyde. That is the smell of cinnamon. And its molecular structure is C9H8O. So for number 20, let's look at number 20. Number 20 has several steps because you have not previously found the molecular mass of cinnamaldehyde. You need to find the molecular mass, and then you can find the amount per mole. Hold on, let me write this down. All right, so let's look at number 20. It says that you're trying to find how many grams are in 0.25 moles of cinnamaldehyde. And again, you have not previously found its molecular mass. So part of the problem is actually finding cinnamaldehyde's molecular mass. So I have C9H8O. C9H8O. How do I find the molecular mass of a substance? Right. The subscripts times the little numbers. So I have the subscript 9. What are the little numbers for carbon?
12.
All right. Plus my subscript, which is 8. What's the little number for hydrogen? All right, and for oxygen, I just have 1. So what's the number for oxygen? Right, 16. So now I need to simplify all my parentheses. So 9 times 12.01. Yep. 108.09. 8 times 1.008.
8.064.
Right. And 1 times 16 is just 16. So now let's add them together. 4, 2. All right, so the molecular mass of cinnamaldehyde is 132.154 grams per mole. Meaning for every mole of cinnamaldehyde, again, a mole is 6.022 times 10 to the 23rd units of this substance's compounds. So for every mole, it'll weigh 132.154. Not necessarily weigh, but that's how much stuff you have. Yes?
So you first multiplied all of them and then you added them.
Yes.
And then you would get your answer, right?
Yes.
And to round.
We didn't round any of that actually.
Okay, but would there be any problems that I would have to round or no? Or it
Yeah, usually we try to keep it at 1 or 2 decimal places.
Okay.
All right. So now we have the molecular mass of cinnamaldehyde, and it's asking, what is the mass of 0.25 moles of cinnamaldehyde? So I have 0.25 moles of cinnamaldehyde. Again, I want to cancel out that mole, so I put the mole on the bottom of my new fraction. Again, so that those cancel out. And for every 1 mole, I have 132.154 grams. The moles cancel out, and I'm left with 0.25 times 132.154. 0.039.
I was like, where'd you get that?
It's like 8.5. So.
What? Okay. So I rounded it to 2 decimal places. That means that if I have a fourth of a mole, so a fourth of a mole of the substance, it is going to have a mass of 33.04. So if you have 33 grams of cinnamaldehyde, you have basically a fourth of a mole of the substance. All right? Any questions on that one?
So for the answer that you got from there, and then on here, the moles, all you did is multiply, and then
Yep.
and then wait. Oh yeah, so you just multiply them, and then you would get your answer. Yep. For the whole problem.
Yep. Yes.
What's the answer?
What's the answer, Paul? It is the mass per mass per 1/4 mole time. All right. So let's move on. So if you notice 21 through 24, we're going to go over those in a few minutes. Those are the ones where you're given a reaction formula, and you need to figure out how many grams you need in order to get this much stuff. And it does involve several, what's it called? Computations, I guess. But we'll go over those in a minute. I'm going to wait for the juniors to get here. So let's look at 25 through, what was it? 34. These are all using the gas laws. This is where you plug in a number and get an answer out. In my personal opinion, I do think that these are the easiest ones, in my personal opinion. I do on the test, I am going to give you Boyle's law, I am going to give you Charles's law, Gay-Lussac's law, the combined, ideal. I am giving you those. And I will give them, and I give it next to the specific problem even, so you don't need to guess which one to use. So let's look at number 25. Number 25, it says use Boyle's law to find, and then it gives the problem. 1 liter of gas at 3,000 millimeters of mercury is switched to a different container. Assume the temperature remains the same, but the gas now has a volume of 4 liters. What is the pressure of this gas now? So first of all, we need to write down what Boyle's law is. What is Boyle's law?
These are pressure.
Measure line.
Right, P1, V1 equals P2, V2. If I were you, I would write it down. This is 25. So 1 liter of gas at 3,000 millimeters of mercury is switched to a different container. So they give you all the information for the start of the gas. They say it has a volume of 1 liter, because liter is volume. And then it says 3,000 millimeters of mercury, which is my pressure. So they gave me my P1, they gave me my V1. So to reiterate what I just said, what's the initial pressure? Looking at the problem, what's the initial pressure? Yeah, it's right out. Yeah. Wow, okay. What is my initial volume?
1 liter.
Liter. And then it says, assuming the temperature stays the same, they switch it to a different container, so different pressure, different volume, and they gave you one piece of information. What piece of information did they give
4
you?
liters.
Right. Now V sub 2 is 4 liters, and we need to find V sub 2. We don't know what it is. That's what we're trying to find. So with these problems, always write down what you're given, figure out what each number means, and then write it down. And now I simply plug in the numbers that I was given. So P sub 1 is 3,000. My volume is 1. My pressure, I don't know, so I'm going to leave a P2, and I'm multiplying it by my volume, which is 4. So I'm going to solve for P sub 2. Right now I'm multiplying it by a number. I want to get P sub 2 by itself. What's the opposite of multiplying?
Divide.
Dividing. So I'm going to divide both sides by what number? 4. Divide both sides by 4. And P sub 2 equals what? What are the units? Millimeters of mercury. Any questions on using Boyle's law?
Nope.
All right. Let's move quickly through the next 2. Let's look at 27. This is Charles's law. So, again, I am going to give it to you. Wait. Okay. I'm going to give it to you. But what is Charles's law? Right. V1 over T1 equals V2 over T2. Now let's read the problem and figure out what they give us. They said a gas exerts a pressure of 22.5 millimeters of mercury on a container. The gas is then moved to a 5-liter container and now exerts a pressure of 14.6 millimeters of mercury. What was the volume of the gas in the first container? So the last part of the problem tells us what we're trying to find. What are we trying to find? Volume of the gas in the first container. So we are actually trying to find the initial volume. That's what we're trying to find. It is the volume of the gas in the first container. Am I looking at the right phone?
27.
I was looking at 26.
Same thing. Wait, are you 26? Yeah, but it's a different. See what is different?
Can we start?
Yes. Let's restart.
Oh yeah.
So number 27. Number 27. Yes.
Sure.
You're only in here for like 10 minutes. Number 27. I'm sorry. Why did I name you stopping?
I was
Okay. So number 27, using Charles's law, says half a liter of gas is held at 0 degrees Celsius in normal pressure. Find its volume when the temperature rises to 50 degrees Celsius. So we're going to be trying to find its, not initial volume. We're trying to find its second volume because it's given an initial volume, initial temperature, and then the temperature changes. So what is that final volume? So what information did they give us? Yes, which is my initial volume. So at 0.5 liters, what was the initial temperature? All right. But do we use it in Celsius?
Yeah.
No, we need to change it to Kelvin. How do we change it to Kelvin? Plus 273. So really 0 plus 273 is 273 Kelvin. And then we're trying to find the new volume. We don't know what it is. But it says find its volume when the temperature rises to 50 Celsius. So now I have 50 degrees Celsius. What is that in Kelvin? 323 Kelvin. And now I can solve, plug in what I know and solve for V sub 2. Again, in all of these gas problems, you have to use Kelvin. You cannot use Celsius or else the measurements don't add up. They all need to be in Kelvin. So V sub 1 is 0.5 liters over T sub 1, which is 273 Kelvin. That equals V sub 2 over T sub 2, which is 323 Kelvin. So I took the information, So I took the information that was given to me, I plugged it into my Charles's law formula. Again, I'm going to give you the formulas. Any questions so far? Yes.
Will you be wearing
You need to know. You need to know how to convert Celsius to Kelvin. You just add 273 to Celsius. So now I need to get V sub 2 by itself. So what should I do? I heard somebody kind of whisper. Multiply. You could cross multiply, but then that actually kind of adds some steps. But right here, I'm dividing between. I have V sub 2 divided by 323. So I do the opposite and multiply both sides by the 323 Kelvin. So cross it out. And then if this part confuses you, this technically you multiply these two top numbers and divide by this. You can just figure out what the fraction equals and then multiply it by 323. All right, so if I multiply this out, what do I get? 0.59. What is it?
You just say this.
Oh, okay. So as you can see, the volume didn't change all that much. It changed by like 900ths. So changed by like 900ths. So this temperature change didn't really change the gas all that much, but it still did have a change. So that is using Charles' law. Now let's use Gay-Lussac's law. Anybody know Gay-Lussac's law?
Same thing, but with pressure.
Same thing, but with pressure. So P1 over T1 equals P2 over T2. So read the problem, figure out what you are given, figure out what you need to find out. 29. So number 29 says, the pressure of a gas when heated to a temperature of 250 Kelvin is 1.5 atmosphere. What was the initial temperature of the gas if the pressure was 1 atmosphere? Can I quietly pull out your study guides? So when heated to a temperature of 250 is 1.5 atmosphere, and we're trying to find what was the initial temperature. So initial is always talking about the first. So obviously, at some point in the problem, they're gonna give me P sub 1, so the initial pressure, and they're gonna give me the final pressure, final temperature. So what was the initial pressure of this gas? What? It's actually 1 atmosphere. Yeah, we're on 29. And then, what was the final temperature, final pressure? All right, 250 Kelvin and 1.5 atmospheres. So, for those that just came in, pull out your study guides. We're on number 29. Everything up to this point I have recorded, so I'll send it to you in a little bit, or later on today. So, again, what P1? P1 is the 1 atmosphere.
You put 2 on.
This is P2.
Okay.
Because you have the 1 atmosphere, they actually gave it to you like opposite. They gave you the final stuff, and then they told you the initial part. So they said it's heated to this, but it started at a pressure of this. So now we need to solve for T sub 1, plug in what I know. T sub 1 is 1 atmosphere over my T sub 1. T sub 2 is 1.5 atmospheres over T sub 2, which is 250 Kelvin. Obviously, my unknown is on the bottom, and so sometimes that tends to complicate things just a little bit. Miguel, sit up. Miguel. You need to sit up. So, how can I get the variable on the top? Or how can I get a single equation without fractions? I can cross multiply. Cross multiply means that I simply multiply across that equal sign. So T sub 1 times 1.5 atmospheres equals 1 atmosphere times my 250. Again, in this case, I cross multiplied because my variable was on the bottom. And so it's difficult to solve when that variable is on the bottom. There are other ways to do it, but I feel that cross multiplying is the simplest. So now I need to get T sub 1 by itself. I'm multiplying, so the opposite is dividing. So I divide both sides by this 1.5. 1 times 250 is 250, so 250 divided by 1.5 is 166.66666. So 166.7 Kelvin. All right. Any questions on Gay-Lussac's law? All right. All right, let's look at the combined gas law. Let's look at number 31. And then we're going to go back to the problem and probably end with that. So the combined gas law, does anybody remember combined gas law?
Nope.
It's all of the gas laws combined.
Yes, I'm doing it.
T1 over T1.
There we go. So obviously I'm going to be given a bunch of information in these problems. Some of them, like number 32, we're not going to go over 32, but 32 says at STP, that's standard temperature, standard pressure. Does anybody remember standard temperature? It is 273 Kelvin. What is standard pressure? Yeah, 1 atmosphere. So, number 31, the combined gas law, it says the initial volume of the gas is 5 liters and then decreases to 3 liters. What is the final pressure if the initial temperature was 273, the final temperature is 200 Kelvin, and the initial pressure is 0.25 atmosphere. So they went through and gave you a lot of information about all of these gases. So you need to write it down, make sure that you understand what information you're given, what you're trying to find. So, what is the initial volume of the gas? 5. What is the final volume of the gas? Is everyone on number 31? Yes. Everyone on number 31? All right. So my initial volume is 5, and then it decreases to 3 liters. And after that, it says, what is the final pressure? So what are we trying to find? P2, that is my final pressure. So that means I should be given everything else in the problem. And then it says if the initial temperature is what? 273. All right. What was the final temperature? All right. 200 Kelvin. And the other thing I need is P sub 1. Does it tell me what the initial pressure was? What is it? Yes. So 1/4 of an atmosphere. And I'm trying to solve for P sub 2. So I have all the information I need, and I can solve for my unknown. So I'm going to take all the information, replace my variables. P sub 1 is the 0.25. V sub 1 is this 5. T sub 1 is 273. Then I have P sub 2, that is my unknown. V sub 2 is 3 times 3. T sub 2 is the 200 Kelvin. All right, does everyone have that? I plugged in what I know. And now I need to get P sub 2 by itself. So, what can I do to get P sub 2 by itself?
Multiply, divide,
I can what? Cross multiply? Okay. So we can cross multiply. And I would get 0.25 times 5 times 200 equals, so that was multiplying the top by the opposite bottom. And I get that. Then multiplying the bottom by the opposite top, so times 3 times P sub 2. Then I need to get P sub 2 by itself. So what do? I divide 273 times 3. 273 times 3. These all cancel out. And then you just basically put it into your calculator. You can put it in the top, so 0.25 times 5 times 200. And then put in the bottom, so 73 times 3. And take those numbers and divide them. I bet, has anybody done it yet? 27. What?
Let's find out.
0.25 times 5 times 200 divided by 63 divided by 3. I got 0.31. Anybody else get that? You got it? Yes.
Is there like a cosmos? Like P1 P2 over
Yeah, that's the same. So I have P sub 2 equals pressure atmosphere. All right. Any questions on that one? All right. So the last few on that page, I was talking about the ideal gas law, PV equals nRT. You can look in your book, in your notes, to understand what each of those variables represent. P is pressure, V is volume, N represents the number of moles. R is your universal gas constant, which will be given on the test. And T is the temperature. Calculating the percent by mass, that's the next section. 35 through 38, percent by mass means that you take the mass of the solute, so the mass of just the part, over the mass of the entire thing, and change it to a percentage. 39 through 42, calculate the unknown quantities using that energy formula. So you have Q, which is your thermal energy, equals M, which is your mass, times the C sub SP, that is your specific heat, times the delta T, that is your change in temperature. So in each of those, you're given the information required, and you're going to solve for a certain variable. And then 43, 44, you're going to use that delta G equals delta H minus T times delta S to calculate if something is reasonable or spontaneous or not. I have 1 minute, and I did not get to go over the reaction question.
We don't need it.
You don't need help with it?
Well, we don't need English.
Oh, I have a final right after this, so
What time do you have?
I'm giving my geometry. Yes.
You can switch.